Now let's talk about the types of discontinuities. Now the term is clear. Discontinuity or discontinuous, ibig sabihin hindi tuloy-tuloy yung graph. Okay, we have the two specific types, the removable discontinuity, and the other we call it as the essential discontinuity. Okay, now first let's talk about the removable discontinuity. We say it is removable by the adjective itself, removable. You can redefine it. Okay, it is also called as the whole discontinuity kasi may butas and then ito na yung dalawang graph. Okay, it's like when you are walking on that path, then bigla kang tatalon, just to move on the next path. It is also called as the point discontinuity because the function is not defined at a single point. Okay, now let's define the conditions bago natin masabi na the function has a removable discontinuity. Okay, first, limit of f of x as x approaches c should exist. Now, on the second, either f of c does not exist or undefined. This can also be undefined. Or f of c is not equal to limit of f of c as x approaches c. So, ibig sabihin nito, dapat mapatunayan natin na yung left and right mag-exist and equal so that A is true, that the limit of f of x as x approaches c exists. Also, kailangan mapatunayan natin na kahit ano dito sa dalawa, f of c ay hindi nag-exist or undefined. Or we can say that f of c is not equal. Take note of that, not equal. Bakit kaya not equal? From that, we can say it is discontinuous. Hindi pwedeng equal sila. Take note yung una nating rule sa continuity. Equal naman yun. Pero dito, not equal. Making it discontinuous as we prove. Okay? It is said to be removable because the discontinuity may be removed by redefining. We are going to redefine f of c so that it will be equal to limit of f of c as x approaches c. In other words, we have this limit, L, a removable discontinuity is remedied by the redefinition. Let limit of f of c as x approaches c equal to L. Or in other words, we are going to make use of the conjugation. The other ways is like the indeterminate forms, rules, para matanggal yung indeterminate forms. Usually, ang connected na term dito is that discontinuity is true when we are referring, when this happened, naging indeterminate ang given function at that. Understand that? Let's have the example, the same example provided to you. So this must be f of -3. Now consider the graph. The graph is here. Nakikita natin na pag ginamit natin ng x that is equal to -3, magiging undefined yung f of -3. And now this means that the function f is discontinuous. That is already proven kanina on the continuity. However, if we're going to redefine it using the factoring technique, we can see here that we can eliminate x plus 3, making it x minus 1 as the remaining function. That's the reason why that's -4 becomes the limit. And tandaan nyo class, by the graphical analysis, as you keep on approaching -3 from either side, both sides, parehong pinupuntahan ng y value, papunta sila sa -4, Itong whole na to, this simply suggests that you can redefine it, okay? And the factoring technique can be used, So, satisfying the first condition, f of -3 is undefined. That's true. Diba? Naging true yung first condition. F of -3 is undefined. Second is, mag-exist yung limit, sabi niya. Mag-exist yung limit, which is true also. The limit exists. The two-sided limit exists. And on the second condition, f of c should be undefined. Nangyari naman yun, f of negative 3 is undefined. And at the same time, we redefined it. We have a redefinition, kaya nagkaroon tayo ng negative 4 as the limit. Ngayon, paano kung tinanong ka naman, removable discontinuity ba ay totoo when x is equal to other numbers except negative 3? Let's say x is equal to 4. Then obviously, hindi na siya removable, kundi continuity is true already. Dahil kung i-substitute mo ang 4 dito sa x plus 3, defined ang f of 4. Okay? Hindi naman kasi nag-0 ang denominator. And definitely, the limit also exists. So continuity is true. Negative 3 caused discontinuity on this given function. Okay, yan na yung condition. Yes, the limit exists and f of negative 3 is undefined. Hence, they are actually not equal. Tandaan nyo class, kapag sinabi ng undefined, no other number can be related to an undefined. Kaya nga undefined, how are you going to relate? So, not equal naman talaga. Therefore, it has a removable discontinuity at x that is equal to negative 3. The second condition, we have here x minus 2. Nakikita natin x minus 2. So, kinamit mo ang x that is equal to 2 as x approaches 2, sabi niya doon. Okay? Ang mangyayari, mapapatunayan mo na discontinuity is also true. First, f of 2 is undefined. G of 2, kasi the function there is. G of 2 is undefined here. See, the whole here suggesting undefined siya. Pero pag i-check mo yung left and right, no? The left and right continuity, pareho ang pupuntahan or limit. They go to 5. So, ibig sabihin, the two-sided limit, no? Of that given function as x approaches 2 is 5. Hence, we can say that g of x has a removable discontinuity at x that is equal to 2. Yung number 3 naman, third example, the graph of as x approaches 1 here, the graph of h of x, this is a piecewise function, no? As x approaches 1, h of 1, no? The value of h of 1 is undefined. H of 1 is undefined here. Let's check clearly. And when you're going to get the limit of h of x as x approaches 1, it gives you 3. Let's check. When x approaches 1 from the left, itong equal sign na ito, ibig niyang sabihin, except 1 only. Sorry, not equal to pala yung in-highlight ko. Itong equal sign, ibig sabihin, 1 lang ang pwede sa kanya. So, a unit set. Ito naman, ang ibig sabihin, tanggalin mo lang yung 1. So, all numbers except 1. So, ibig sabihin, left of 1, ito pa rin ang gagamitin mo. At saka right of 1, ito pa rin 2x plus 1. So, bibigyan niya talaga ng 3. Okay? And since h of 1 is undefined, then we can now say that it has a removable discontinuity at x that is equal to 1. Now let's move to the second type, that is the essential discontinuity. Essential discontinuity, here we have the first type, that's the jump discontinuity. Pero when do we say that essential discontinuity is true to the given function at a given x? Mangyayari daw yan kung ang limit ng function ay d and e. If you go back to the removable discontinuity, the limit should exist. Yun ang sinasabi niya. Kasi kung graphically speaking naman kasi, they meet, no? They are approaching the same value, y. However, for essential discontinuity, ang limit does not exist. Okay? Tandaan natin na kapag ang limit ay infinity, that is technically defined as d and e. However, you have in the rule kasi, because you are describing the behavior of y, then you have to write positive or negative infinity. Okay, let's have the jump discontinuity. We say that there is a jump discontinuity on a given function if for a function f, the limit does not exist because the limits from the left and right of x that is equal to c both exist, no? Pero hindi sila equal. Tandaan ulit natin, kailangan mag-exist at dapat equal. Yun yung condition. That is, limit from the left is L, limit from the right is M, and these two are not equal. Kaya siya jump. So parang, kumbaga, you are moving to the next path. Okay? So, tatalon ka talaga. No? So parang literal siya na tumalon ka just to move on the next path. Okay? And this is also known as step discontinuity. So when you jump, then you have another step. So parang maybe yun ang kanyang term, no? In number 1, you can see here magkahiwalay ang dalawang graph, pero kung titignan mo yung limit, nag-exist naman talaga. This is 2. So ang left ng 2, bibigyan kanya ng 3 as seen on the graph. Right of 2, bibigyan kanya ng negative 3. Nakikita ulit natin dito. This is negative 3. So 3 and negative 3 are not equal, though they both exist. Then the limit should not exist. The two-sided as x approaches 2. And at the same time, dahil nangyari nga yung DNE, jump discontinuity na siya at x is equal to 2. Papatunayan mo lang na hindi mag-exist yung limit. At the same time, kailangan mag-exist ang limit ng left at right. Pero when it comes to two-sided limit, the limit should not exist. So step discontinuity siya or jump discontinuity. So parang ito, as x approaches 4, when you check left of 4, ito kasi ang left of 4 eh. So 4 plus 1, left of 4 plus 1 is 5. Right of 4, so yung isang function naman, no? 4 minus 4, 0 squared plus 3, 3. So 5 and 3 nag-exist, pero hindi sila equal. So graph also can prove that to you graphically. Ibig sabihin, ang limit ng function na yan as x approaches 4 ay hindi nag-exist. Then jump discontinuity is true at x that is equal to 4 to the given piecewise function. So chinek lang natin kung nag-exist yung left at right at ang limit, two-sided limit ay hindi nag-exist. Okay? So that is for the jump discontinuity. For the infinite discontinuity, the term itself infinite, kailangan yung limit, two-sided limit ay hindi mag-exist. Tapos yung left or right ay laging may infinite limits. Okay? Doon nagpapakita ang tinatawag na infinite discontinuity. Now, observe the graph of f of x, 1 over x squared. When x approaches 0 from the left and from the right, pareho ang pinupuntahan ng values ng y. Yan, nagpakita ang positive infinity and positive infinity. And again, technically, infinity does not exist because infinity is not a real number. Hence, we can say that f of x has infinite discontinuity at x that is equal to 0. Okay, number 2, 1 over x, very popular graph. Left of 0 is negative infinity. Ito siya. Right of 0 is positive infinity. So there you go. H of x has infinite discontinuity at x that is equal to 0. Now, how about this? 1 over x minus 4. On the right of 4, positive infinity, paakyat siya. On the left of 4, negative infinity pababa. So there is infinite discontinuity at x that is equal to 4. At mapapansin nyo din dito, class, ng vertical asymptote, no? Magiging vertical asymptote yung line na yan, x that is equal to 4. Di ba? Kapag may asymptote, ibig sabihin may infinity. Yun yung sinabi ko sa inyo during the midterm. If there is an asymptote, there is an infinity. Okay? And to sum them up, the flowchart is here, shown to you. Kapag ang limit ay nag-exist, let's have yes. So ibig sabihin continuous siya or may removable discontinuity. And are they equal? Limit of f of x as x approaches c is equal to f of c. If you say no, then removable discontinuity. If you say yes, continuous siya. And does the limit exist? You say no, then you have to check the one-sided limits. Kung hindi nag-exist, no. Bakit no dito? Ang sinasabi niya kasi, kung infinity, negative infinity, ganyan, they are not technically termed as exist. Okay, so kung no, infinite daw ang infinite essential discontinuity or infinite discontinuity. Kung sinabi mo namang yes, nag-exist yung left at right, jump naman siya. So, kung nag-exist ang left, nag-exist ang right, so yun din yung sinasabi niya, class, no? Na there's a jump discontinuity. So you have to check all the conditions, and this flowchart can also help you understand the two types, the removable discontinuity and the essential discontinuity.